In this part of the lesson, we're going to talk about the multiplication and division of real numbers. We'll spend most of our time talking about multiplication and trying to understand why the rules for multiplication work as they do. We're going to start by talking about multiplication as repeated addition. This is an elementary idea, but it's one that will allow us to start understanding the rules for multiplication of real numbers. Then we're going to talk about the rules for multiplication of real numbers. We'll do a brief review of division, and once we've done that, the rules for the division of real numbers will follow very easily. Finally, we're going to have to discuss why division by zero is undefined. So let's start with multiplication as repeated addition. This is really the way we learned multiplication when we first started to multiply. So 3 times 4 can be thought of as 3 occurrences of 4, or as 4 added to itself 3 times. And 4 plus 4 plus 4 is 12, which we know 3 times 4 equals 12. Now this idea also works if we throw a fraction into the problem. 3 times 1/2 means 3 occurrences of 1/2, or 1/2 plus 1/2 plus 1/2. And in this problem we have 3 fractions with a common denominator. We add the numerators and write the result over the common denominator. So 3 times 1/2 is 3/2. When we talk about multiplication of real numbers, we need to throw negative numbers into the mix. So how do we understand multiplication as repeated addition if one of the factors in the product is negative? So let's look at the product 3 times -4. Using this idea of repeated addition, this would mean 3 occurrences of -4, or -4 added to itself 3 times. Now here, we're adding 3 negative numbers. They all have the same sign, so we know the result is going to be negative, and we just add the magnitude of the 3 numbers. So the result is -12. So we ended up with this result, 3 times 4 equals -12. A positive number times a negative number is negative by using this familiar idea of multiplication as repeated addition. So now let's look at the product -3 times 4. So using the same idea, this would mean -3 occurrences of 4, a really kind of bizarre idea. So what I'm going to do is I'm going to change the order of the factors and write the same problem as 4 times -3. We've been doing this with multiplication all along. So this would mean 4 occurrences of -3, which I can write as -3 plus -3 plus -3 plus -3. And here I have 4 negative numbers. I know the sum will be negative, and I just add the magnitude of the 4 numbers, and I get -12. So once again, I'm multiplying a negative number by a positive number, and I end up with a negative result. So we have a rule here for the product of 1 positive and 1 negative real number. The product of 1 positive and 1 negative real number is the opposite of the product of the 2 numbers' absolute value. The result is negative. So what does this mean? What do I do in my head? If I see a problem like 5 times -4, I know the result is going to be negative, and the multiplication I'm doing in my head is 5 times 4. I'm taking the product of the magnitude or absolute value of the 2 numbers. The order of the factors does not matter since the commutative property holds. It's the commutative property that allows us to switch the order of the 2 factors in this problem. So now we need to ask, what happens if both factors are negative? That would mean, what does it mean to add -3 to itself -4 times? Well, now this idea of repeated addition is really not helping us a lot. So we're going to have to look at the question another way. So we're going to start with a real easy question. What happens when we multiply a real number by 1? Well, 3 times 1 is the same as 1 times 3, and that's 3. So when we multiply a positive number by 1, that leaves the result unchanged. Same thing is true with a fraction. 1/2 times 1 is the same as 1 times 1/2, which is just 1/2. So when I throw a factor of 1 into the product, it doesn't change the product at all. And 1 is called the multiplicative identity. And I can write this in general. If A is any real number, I can write that A times 1 equals 1 times A, which is just A. This is a formal way of stating that 1 is the multiplicative identity. So now we want to think about what happens when we multiply a real number by -1. Well, if I take 3 and multiply it by -1, we talked about what we would do here. We know the result is going to be negative, and we just multiply 3 times 1. So the result is -3. This would work with fractions as well. -1 times 3/4. I know the result is negative. In my head, I just multiply 1 times 3/4, and I get -3/4. So if I use the letter A to represent any real number, it looks like what's happening is when I multiply a number by -1, I'm getting the opposite of the number. So now, let's just think about what might happen if A was a negative number. For example, if A was -2, then according to the pattern we've seen here, we would get the opposite of -2, which would be +2. So it looks like whether A is positive or negative, that we're changing the sign of the number when we multiply it by -1. But I'd like to take a minute to look at this another way. So we're still thinking about this question, what happens when we multiply a real number by -1? So we're going to look at a table. We're going to try to find a pattern in the table and then use the pattern to complete the table and see if we can derive some rules. So here's our table. The table is giving us multiples of -3. The first factor in all of these products is -3. So let's start by looking at the product of -3 and +3. Using repeated addition, we were able to convince ourselves that that equals -9. -3 times +2 equals -6. -3 times +1 is -3. Now at this point I want to pause for a moment and look at the pattern that's emerging. The first factor in all of these products is -3. The second factor in the products these second factors are decreasing by 1. We're going from 3 to 1, we'll go to 0, -1, and -2. Look what is happening to the result. -9, -6, -3. Our results are increasing by 3. So I would expect, if this pattern continues, that my next result should be 0. -3 plus 3 is 0. And look at the product I have here. -3 times 0 equals 0. I'm sure you've been told that when you multiply a number by 0, the result is 0. And the nice thing here is that that's emerging from the pattern we're seeing in the multiples of -3. So let's continue. If I add 3 to 0, I get +3. So according to this pattern, -3 times -1 should be +3. Multiplying negative 3 by negative 1 is changing the sign of the number. Let's take this one step further. If I add 3 to 3, I get 6. So when we see this pattern emerge, we see that negative 3 times negative 2 should equal positive 6. So we're looking at the product of two negative numbers, and we're ending up with a positive result. So multiplying a non-zero real number by negative 1 changes the sign of the number. So negative 1 times 3 equals negative 3. We can change that to a general statement. Negative 1 times any real number equals the opposite of that number. Now here's the rule for the product of two negative real numbers. The product of two negative real numbers is the product of the two numbers' absolute value. The result is positive. So if I take two negative numbers like negative 10 times negative 2, I know the result is positive, and the arithmetic I do in my head is I just multiply 10 times 2. So let's summarize the rules we've discovered for multiplying two non-zero real numbers. When multiplying two real numbers, first multiply the absolute value of the numbers. This is the arithmetic we're doing in our head. 5 times 3, 3 times 4, 10 times 2. If both factors are positive, the result is positive. If both factors are negative, the result is positive. This is the new idea. If one factor is positive and the other negative, the result is negative. So now let's look at a product of three factors. So in this example, I have three factors. I have two positive factors and one negative factor. And when I do this problem, I'm going to do the operations from left to right. So first I'm going to multiply 2 times negative 3. And that product is negative 6, which I still have to multiply by 6. Negative 6 times positive 6 is negative 36. So in this example, I had several factors and one negative factor, and the result was negative. In this problem, I have three factors, and all of the factors are negative. Again, when I perform the multiplication, I'm going to perform the multiplication from left to right. So I'm going to start by multiplying negative 3 times negative 2. That will give me a positive 6, which I need to multiply by negative 5. 6 times negative 5, I have one positive, one negative number, so the result is negative, and I just multiply 6 times 5 in my head. So I get negative 30. So in this example, I had three negative factors. The result was negative. So now let's look at an example where we have two negative factors. Now you may notice that when I'm writing this problem, I'm using parentheses around some of the negative numbers. And I'm doing this so you don't mistake multiplication for subtraction. When you're working with negative numbers, if you just see a 2 with a negative 3 next to it, and you don't see the symbol for multiplication, you might think that this is a subtraction problem. So sometimes we use parentheses for multiplication when we have negative numbers thrown into the problem. So now let's do the arithmetic. Again, I'm going to operate from left to right. So the first multiplication I'm going to do is negative 4 times positive 2. And that is negative 8. Now I'm going to multiply negative 8 and negative 5, then multiply the result by 3. So negative 8 times negative 5 will give me a positive result, and 8 times 5 is 40. And finally, 40 times 3 is just 120. So in this example, I had two negative factors among my factors. The result was positive. One last example of this type. We're going to look at a problem where we have 4 negative factors. And again, I'm going to multiply the factors from left to right. So negative 2 times negative 3 is positive 6. 6 times negative 6 is negative 36. And when I multiply negative 36 by negative 1, that changes the sign of 36. Or we can just remember we're multiplying 2 negative numbers. The result is positive. So I'd like to summarize what we just did in these problems. In the first example, we had 1 negative factor and the result was negative. In the second example, there were 3 negative factors, the result was negative. But in these last 2 examples, we had a positive result. And in both of these examples, there's an even number of negative factors. And when we have an even number of negative factors, we can kind of pair them up. And in this first example, negative 2 times negative 3, that's giving me a positive result. Negative 6 times negative 1, that's giving me a positive result. So the whole result will be positive. Here, we have an odd number of negative factors, and there's no pairing up going on. If we pair up the negative 3 with the negative 2, in this example, we still have this oddball negative number left over, which makes the result negative. So let's summarize all the rules for the multiplication of real numbers. If a product contains no factor of 0 and an odd number of negative factors, then the result is negative. If a product contains no factor of 0 and an even number of negative factors, then the result is positive. And finally, the property of 0, if we multiply 0 by any real number, the result is 0. We're going to take just a couple of minutes to review division. We're going to start with dividing 2/3 by 5/3. And remember that when we divide fractions, we start by taking the first number in the quotient and multiplying it by the reciprocal of the divisor, or the second number in the quotient. We multiply numerators, multiply denominators, and in this problem we notice that there's a factor of 3 common to both the numerator and denominator. 3 over 3 is 1, so we're left with 2/5. But the essential idea here is we started by turning our division problem into a multiplication problem. This would work with even the simplest of division problems. 18 divided by 6. We know that's 3. But will the same trick work that we used when we were dividing fractions? Can I take 18 and multiply it by the reciprocal of 6 and get the same result? Well, if I write 18 as 18 over 1 times 1/6, multiply numerators, multiply denominators, it's pretty clear that that is 3 as well. So every single division problem can be written as an equivalent multiplication problem. I also want to point something out here as well, that this way of writing division, it's going to go away very soon. And most of our division problems will be written using the fraction bar instead. So here's the definition of division. If a and b are real numbers and b is not equal to 0, then a divided by b equals a times the reciprocal of b. The quotient of a and b is just a product of a and the reciprocal or multiplicative inverse of b. So every division problem is just a multiplication problem. Now I want to point out the similarity between the definition of division and the definition of subtraction. If a and b are real numbers, then a minus b equals a plus the opposite of b. So the difference of a and b is the sum of a and the opposite or additive inverse of b. So you can see the parallel here. Subtraction is defined in terms of addition, division is defined in terms of multiplication. The good news is that this will make the rules for the division of real numbers real easy, because we just went through understanding why the rules for the multiplication of real numbers behave as they do. So here's a summary of the rules for dividing real numbers. When dividing two non-zero real numbers, first divide the absolute value of the numbers. This is the arithmetic we're doing in our head. If both numbers are positive, the result is positive. If both numbers are negative, the result is positive. If one number is positive and the other negative, in this case, the result is negative. Now notice here, I specified non-zero, because when we throw 0 into the mix, some things are going to change. Dividing 0 by any non-zero number results in 0. So what does this mean? This means that 0 divided by 4 equals 0. Dividing 0 by any non-zero real number results in 0. Or as a fraction, I might write 0 over negative 2 equals 0. Division by 0 is undefined. This means I cannot write 4 divided by 0. Or if I do write it, I need to specify that this just doesn't make any sense. It's undefined. Also, a fraction in the form 7 over 0 is undefined. So now we have to think about, why is division by 0 undefined? So what we're going to do is we're going to look at 3 quotients, and we're going to think about equivalence statements using multiplication. So in the first example, we're going to look at 8 divided by 4 equals 2. Now the reason why I know 8 divided by 4 equals 2 is because 2 times 4 equals 8. That's an equivalent statement. 21 over 3 equals 7 because 7 times 3 equals 21. So let's look at 0 over 3 equals 0. We said that 0 divided by any non-zero real number results in 0. This would be because 0 times 3 equals 0. So every division problem sort of has this equivalent multiplication problem lurking behind it. So now let's think about the quotient 20 over 0. We want to understand why this is undefined. Well, what I'm going to do is I'm going to pretend it has a definition, and I'm going to let the letter m represent this mystery quotient. And now I'm going to write 20 over 0 equals m. So what would the equivalence statement about multiplication be? Well, if we look back at the previous slide, we see that if we had 21 divided by 3 equals 7, that meant 7 times 3 equals 21. So 20 over 0 equals m, that would be equivalent to m times 0 equals 20. I hope you see that something is wrong with this statement. If I take any number and multiply it by 0, I shouldn't be getting 20. The statement m times 0 equals 20 is never a true statement. So 20 divided by 0 cannot equal m. Can't be defined. A related question is the question, does 0 have a reciprocal? There's a couple of ways to look at this. I'm going to start by writing 0 as a fraction, because I know that 0 divided by 2 is 0. And once I have 0 written as a fraction, then I'll be able to think about a reciprocal. Well, remember how we find reciprocals. We switch the role of the numerator and denominator. If I write 2 over 0, some flares should be going up. I should recognize that this is undefined, that I can't write this, no matter how much I want 0 to have a reciprocal. So 0 does not have a reciprocal. Another way to look at this is just to take any number, like 2/3, for example, and multiply 2/3 by its reciprocal. What do we get? We get 6 over 6, which is 1. So whenever we take a number and multiply it by its reciprocal, the result is 1. So if I take 0, is there some mystery number I can multiply 0 by to get 1? Well, we know this is impossible. When we take 0 and multiply it by any number, we'll get 0. So the number 0 does not have a reciprocal. In fact, it's the only real number that doesn't have a reciprocal. Let's just finish up with a few examples. We're going to start with 3 division problems, very straightforward division problems, but we have some signed numbers thrown in here. So I'm going to start with -15 divided by -3. I'm dividing 2 negative numbers. I know the result is positive, so the arithmetic I'm doing in my head is just 15 divided by 3, which is 5. How about -15 divided by +3? The arithmetic I'm going to do in my head is going to be identical. 15 divided by 3 is 5. But in this case, the result is negative because I'm dividing a negative number by a positive number. Finally, 15 divided by -3, you should see that this is -5 as well. Now, one of the things I want you to notice is that these 3 expressions, the opposite of 15/3, -15 divided by 3, and 15 divided by -3, are equivalent. We see situations like this in algebra all the time. For example, later on in algebra, we'll see a fraction like -4/5. And in some situations, we'll want to interpret this as -4 divided by +5. And in other situations, we may want to interpret this as +4 divided by -5. So we'd like to be able to recognize that all 3 of these are equivalent. Okay, let's do a fraction problem, throwing negative numbers into the mix. 3/4 divided by -5/4. I know from the get-go that the answer is going to be negative. And I'm going to change the division problem to a multiplication problem. So this will be 3/4 times -5/4. If I kind of pull the negative out front and do the fraction arithmetic, I forgot to take the reciprocal of the divisor. Let me fix that. So the reciprocal of 5/4 is 4/5. And I see that I have a factor of 4 common to the numerator and denominator, and I'm left with -3/5 as my result. These 2 last examples should go very quickly. -5 divided by 0, we should be getting a little warning sign going off in our head right now because we've mentioned that this is undefined. 0 divided by -2, really no arithmetic to do here. 0 divided by -2 is just 0. Okay, 0 divided by 0. This is a tricky question, but we want to spend just a couple of minutes talking about it. If you look at this problem and you say 0 divided by 0, undefined, you know, that's a pretty good start. Probably a little bit better to think that 0 divided by 0 is undefined than to think it might be something else. But let's look at this a little bit closely. Suppose I told you that 0 divided by 0 was 1. And the way I argued it is I would say, well, look, 1 times 0 equals 0. Remember how we were writing division problems as equivalent multiplication problems. But then Candace walks in the room and she says, no, 0 divided by 0 is 1/4. And the reason why that's true is because 1/4 times 0 equals 0. And then Steve walks into the room and he says, okay, well, 0 over 0, I want that to be pi. And why is it true? Because pi times 0 equals 0. All of these are true statements. And you can imagine that anybody could walk into the room and say 0 over 0 equals my favorite number. So if I let m represent the mystery quotient again, and I write 0 over 0 equals m, if we look at the equivalent multiplication statement, the statement m times 0 equals 0 is always true. It doesn't matter what the value of m is. So mathematicians have a fancy name for this. They say the expression 0 divided by 0 is indeterminate. We can't pin it down. We can't say it's pi. We can't say it's 1/2. There's no way to determine the value of that expression. Kind of a bizarre idea. Let's just take a minute to summarize our rules. The product or quotient of two positive or two negative real numbers is positive. The product or quotient of one positive and one negative real number is negative. A product or quotient of non-zero factors that contains an even number of negative factors is positive. A product or quotient of non-zero factors that contains an odd number of negative factors is negative. Multiplying a number by 0 results in 0. Dividing 0 by any non-zero number results in 0. Division by 0 is undefined. And you can leave this in your mind for a couple of years, because that's when it will probably come back up again. But the expression 0 divided by 0 is called indeterminate.